For the second part of our Test 1 review, we're going to look at Part 1, Problems 5 through 10. In this first video, we're going to take a look at the first half of the test, which covered problems from Chapter 1. So let's start with the very first problem. In Problem 5, we're asked to solve the equation x subtract 3 times x plus 4 equals 30 by factoring. The first thing we need to realize is that this equation is not factored, since the 30 on the right-hand side would need to be 0 if this were a factored form. So that means we actually need to multiply and combine like terms before we can actually factor. So let's go ahead and do our multiplication. So x subtract 3 times x plus 4 will give us x squared for x times x, subtract 3x plus 4x minus 12, and then on the opposite side we still have our 30. So combining like terms, we get the quadratic x squared plus x when we take the minus 3x and the plus 4x and combine those, and then moving through the 30 over to the left side gives us a minus 42 for our constant n equals 0. So now we have our quadratic in standard form and we can factor it. So we need two numbers that multiply to negative 42 and sum up to 1 when we add them together. So that's going to give us x plus 7 times x subtract 6 is equal to 0. So we now have our factored form. To solve the equation, we now take our individual factors and set them equal to 0, applying the zero factor property. So that tells us that x is equal to negative 7 is a solution to our equation, and x is equal to positive 6 is also a solution to our equation. In problem 6, we're given a second quadratic equation, but this time we're asked to solve the equation using the quadratic formula. So we need to make sure that our equation is in standard form, and indeed this time it is. So that tells us our value for a is equal to 1, our value for b is equal to 12, and our value for c is equal to 33. So now all we have to do is plug this into the quadratic formula and simplify. So x equals minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So now we need to go in and simplify this thing. So combining the values underneath of the radical, we'll end up with the square root of 12. And now we need to simplify the square root of 12. So 12 is 4 times 3. That means we can take the square root of 4, 2, and that leaves the root of 3 behind. And now we can reduce the fraction. So that gives us two solutions. Minus 6 plus the square root of 3, and also minus 6 subtract the square root of 3. In problem number 7, we're given a quadratic equation in standard form and asked to find the exact value of the discriminant. So remember that the discriminant is b squared subtract 4ac. So b squared is 144, a is equal to 4, and c is minus 9. So we plug this into our calculator and we come up with a discriminant of 288. Then in part B, it asks us to use that discriminant to determine the number and the type of solutions to the equation. Since 288 is positive, that tells us that we're going to have two real solutions. And then the problem asks us to break this down further. It says, determine whether the real solutions are rational or irrational. So now we need to know whether or not 288 is a square. It turns out that 288 is not a square. So that means that it does not have a square root, which is a rational number. So since 288 is not a square, we can conclude that the equation has two real, irrational roots. Since 288 is positive, but not a square. And there we go. In problem number 8, we're asked to solve the inequality absolute value of the quantity 8x subtract 4 is less than 16, and we're supposed to write the exact solutions in interval notation. So the first thing we need to do is get rid of that absolute value. So we need to look at our inequality symbol. Since this is a less than, that tells us that we are dealing with an and inequality. So this means that on the negative side of the number line, 8x subtract 4 has to be greater than negative 16, and on the positive side of the number line, 8x subtract 4 is less than positive 16. So now that we've got our and inequality, we need to solve both sides for x. So we have 8x is greater than negative 12. X is greater than minus 12 over 8, and that will reduce, so x is greater than minus 3 over 2. On the other side, we have 8x is less than 20. Again, we divide by 8, so x is less than 20 over 8. And finally reduce, x is less than 5 halves. Now we need to change this into interval notation. X is greater than minus 3 halves is the open interval from minus 3 halves to infinity. The word and means take the intersection, and then x is smaller than 5 halves is the interval minus infinity to positive 5 halves. So now we need to write the intersection of these two intervals. So we see that minus 3 halves is the smallest number shared by the two intervals, and positive 5 halves is the largest number. So our final answer is the open interval from minus 3 halves to positive 5 halves. In problem number 9, we're given the equation of a circle, x squared plus y squared plus 16 equals 6x subtract 8y. And we're asked to do three things: to put the equation into standard form, to write and label the coordinates of the center, and then to find and label the value of the radius. So let's start by getting our equation into standard form. We need to collect together x terms and y terms and move constant terms to the opposite side of the equation. So let's write this as x squared subtract 6x plus y squared plus 8y is equal to negative 16. Next, we need to complete the square in x. So we'll look at the value in front of the x term, minus 6. We'll cut it in half, minus 3, and square it, plus 9. So we add 9 to both sides of our equation. Next, we complete the square in y. Half of the value in front of y, 8, is equal to 4, and 4 squared is equal to 16. So we add 16 to both sides of the equation. Now that we have perfect square trinomials in x and y, we factor. So we now have x subtract 3, the quantity squared, plus y plus 4, the quantity squared, is equal to 9. So that's the standard form of the equation of our circle. Now we can read the coordinates of the center from the equation. The value being subtracted from x is the x-coordinate of the center, and the value being subtracted from y is the y-coordinate of the center. Since it says y plus 4, we're actually subtracting negative 4. So the center is 3, negative 4. The constant term, 9, is the square of the radius. So that means to get the actual radius, we take the square root of 9, which is 3. The final problem of part 1 is a word problem. Sam can process a batch of insurance claims in 5 hours working alone. Jamie can process a batch of insurance claims in 4 hours working alone. How long would it take them to process a batch of claims if they work together? We're asked to write the solution in hours and minutes and to round to the nearest minute. So first, we need to define our unknown. The question is, how long would it take them to process the batch of claims if they work together? So let's allow that to be x. So x equals time to process claims together. Now, our basic formula in these sorts of situations is that the work done is equal to the rate at which you do the work times the time at which you do the work. Well, Jamie and Sam are going to process one batch of claims, so that's the work done. We need to know the rate at which they work. It says that Sam can process a batch of claims in 5 hours, so that's one batch in 5 hours. Jamie can process a batch of claims in 4 hours, so that's one batch in 4 hours, or 1/4. If we take their individual rates and add them together, that gives us their rate working together. And finally, the time that they're going to work together is x. So we now have an equation which will allow us to solve for the quantity we wish to know. Let's go ahead and get rid of those fractions. The LCD for 5 and 4 is 20. So if we multiply by 20, we get 20 is equal to 4 plus 5 times x, or 9x. So 20/9 is equal to x. So if we go ahead and change 20/9 of an hour, that'll give us 2 hours and 13 minutes. So our last step is to go ahead and write our sentence. It will take Sam and Jamie (2 hours and 13 minutes) to process the claims, and we're all done.